discovered this. Some of you have not. Fine. What?
No.
Shh. What? You guys let me know when you're ready. I'll wait for everyone. Okay. So if you go stat tests and you get to this list, t-test is what we were just doing. And this would be a way to kind of shortcut the TCDF and p-value and all that stuff. And you're welcome to use it, but you still have to know how to do the other stuff. Also, one of the cool things about this, so this is what we just did, you can hit calculate, which will give you, there's your t-value, there's the p-value we just had, it tells you x bar, so it goes through all that stuff. So that's pretty helpful. You could also hit draw, which is kind of cool. It'll show you basically the drawing that we're supposed to make. I think. There we go. So there's your normal curve, and then it should shade like the lower hand part. You can't really tell because the p-value is so small, but it's actually shading over there. Can you kind of tell? Yeah, I don't know, but let's try to zoom in. No, because there were only 2 tick marks before, weren't there?
Well, it's done doing it, so now it's...
It's done?
Yeah, I just stopped.
That was terrible.
What?
Awesome. Alright, anyway. Yeah, that's beautiful, right? So, what I really... The point of what I'm trying to... So, 2 things. I want to show you the t-test so you can use that to calculate. Because you guys are doing the math by hand on that, or you may have been. This is a way to check it, shortcut it, verify, whatever. Now we're going to get into Z. So what's the difference between T and Z? Z is proportions. There's a thing called a Z-test, which is absolutely useless. I want to show you why. So we're never going to use Z-test. We're going to use one prop Z-test. Z-test, if you click on it, it says, so remember the whole point of this. Like we have a small set of data, and we want to use that small set of data to make some kind of guess about like the big picture, right? That's like the point of everything we're doing. When you go to do a Z-test, it says, okay, what's the population mean? What's the population standard deviation? And then it asks you, what's your sample mean? Well, if I know the population mean and the population standard deviation, is there any point in me doing anything to make a guess? None. Like, in a Z-test, you know all of the information that you're supposedly trying to find. It's a waste of time. It's like going through a process to make sure you can do a process, but there's no reason we'll ever use straight-up Z-tests. So we will use, because that's a mistake people make a lot, we will use one prop Z-test. So I think about that, like we have one proportion, we have one sample, and then this is where we can do this. But don't ever use Z-test because it's useless. One prop Z-test, it does not slide. So that's why it's called one prop Z-test, not Z-test. Z-test is a waste of time. Alright, on a t-test, what's the first thing I did? Find mu, so now I'm going to define P. So P equals true population proportion, and then whatever, but context. HO will still be P equals something. HA could be greater than, could be less than, could be not equal to that same something. Those will be decimals. So it might be like P equals 0.75, P is greater than 0.75. You're doing, when we did the Z interval, those were always decimals too. Then you got your conditions. What's the first condition? So randomness. Second one? two options there. So assume each whatever is independent, or our sample is less than 10% of the population. And then 3 is normality. And there's 2 ways we could do this one too. You remember from the Z intervals. Everybody got me here? So you can do the n times p is greater than or equal to is 10, right?
10.
Yeah.
No, I said 3. I thought it was 30.
No, that's the sample size has to be greater than 30 for a t-test. This is going to be, this is the n times p is greater than or equal to 10 is like saying at least 10 successes. What?
Isn't it p hat? Or is it?
Yes. Yes, thank you. So you could do either one of those. If you remember, sometimes they'll give you the numbers, and you can just say, yeah, there's 10 successes. And sometimes you have to do the calculation. Then you also have to do the failures. So either n q hat is greater than or equal to 10, or at least 10 failures. So you can do either one of those that you prefer. Usually depending on what they give. That's the same conditions as all the interval stuff. Good so far? What goes next for any test? Standardized test statistic. Yep. So that's on your formula sheet or whatever. Okay. All right. Alright, what is the standardized test statistic that we're looking for in this case? Z. The statistic is the sample. So what, how do I represent the sample here? P hat. How do I represent the parameter here? Just regular P. Sometimes you'll see like a P0, like a P sub 0, and what that's doing is trying to relate back to this H sub 0. You don't need it, but you can put it if you want. Okay, it's whatever. PO, whatever you want.
I was trying to figure it
It's 0, it's a null. Null hypothesis. So like that they're trying to relate back to that. You don't have to put that, but you might see it just in case you're wondering what it is. And then the standard deviation of the statistic. Well, we have a sample proportion. Do you guys remember the standard deviation? Or it's in the formula sheet of a sample proportion. What?
It's the square root of the standard deviation of the population.
Oh, wait, no.
I think you were doing this, the means. Yeah. So it's the square root of, I didn't write that very legibly, but square root of p hat times q hat over n. Shut up.
Looks better than mine.
And then, then you put in the numbers. And you'll get a Z. Then you're going to use that Z to get what? Like what do we use the T for? To get a P value. And it depends on, remember it depends on what we have up here. So should I go through like the 3 possibilities and put all of it? Okay, so if P than whatever, then you're going to do normal CDF negative 999 comma Z, and your sketch will be will look like that. So if you look to the left, I didn't put degrees of freedom. Remember, you don't need degrees of freedom for proportions or for Z's. Yeah.
We get marked down. I feel like so you have both P's there. You feel like forget like the half. Is that like automatic?
Here,
No, for the graph when you graph or when you draw it out.
like if you put P here and P here, that's an issue, yeah, because then I'm like, okay, which one is actually P? You know what I mean? So P is always in the middle, like the regular straight up P.
And you can put the P 0 there.
You could, yeah. Okay. If P was greater than, in like the original setup, now we're looking at the right hand tail or the top end. So I would do normal CDF Z comma 999. And my graph would flip around. I'd have Z on the right hand side and P hat on the right hand side. And then, am I going too fast or are we good? Alright. If P is not equal to whatever, you can do actually either one of the two that we just did, but what do you have to do with it at the end? You have to double it. So I want both tails. So I'm going to write both tails. Find one, and then double it. And then your graph would represent both tails also. So you'd have P hat and Z with shaded over here, and you'd have P hat and Z shaded over there. And hopefully you left more room than I did. You don't need degrees of freedom for Z. Alpha you need, I'm going to write it in a second. So we can put alpha wherever. Just put alpha equals whatever it is at some. Literally, you can put it wherever. They're obligated to create the entire sheet of paper. You can put it last, you can put it first, you can write it in the middle. It doesn't really matter. We good so far? Yeah.
Default value for alpha different for Z or
Nope. Still 0.05. So if I don't tell you alpha, it's always 0.05. And then your conclusions. So, I'm kind of out of room, but your options are, since p-value is less than alpha, what would we do in that case? We would reject HO. So we do or do not think there's enough evidence for HA? We do. Because I would only reject HO if I'm like convinced enough to go to HA. So we do, or there's, I think I wrote this differently before. There is enough evidence to support HA. We do think P is greater than or less than or not equal to whatever. So there was enough to convince me that P is not equal to what HO claimed it was equal to, so I'm jumping over to that other option. And whatever this one was in the original, you would say, okay, we do think that's true. Or, since p-value is greater than alpha, now I'm not convinced. We fail to reject HO. You gave me this this other option, but I'm not. There's not enough evidence to convince me. There's not enough evidence to support HA. We do not think P is greater than, less than, not equal to, whatever. So you gave me this other option, but I'm like, I'm not convinced. You did not give me enough evidence to jump off of my original assertion. I don't think what you're offering as an alternative conclusion is true. Yeah. Can't call me a truther, but I'm not going to call you a liar. Alright, questions there? Alright, we don't really have time to start a new one, so I'd like to do an example. We'll do it tomorrow. That's fine. Do you want that back up there?